Good morning, children. Welcome to mathematics class, chapter 4, Powers and Exponents, part 8. In today's class, you are going to learn one sum which is left over from exercise 4.1 and sums from exercise 4.2. I hope you might have understood the sums which are explained from exercise 4.1 very well. In 4.2 exercise, you are going to learn in today's class is only how to convert the very large numbers and very small numbers into a standard form. So let us see how to convert that into a standard form. So the leftover question from exercise 4.1, simplify and give reason. 4 by 7 to the power of minus 5 into 7 by 4 to the power of minus 7 into you have to simplify this. So you know that a power minus n is equal to 1 by a power n. So using the law of exponent, you have to convert the negative power into a positive power and then write the reciprocal of 4 by 7. That is 7 by 4 whole power 5. And this 7 by 4 reciprocal is 4 by 7 and change the negative power into a positive power. Now expand it. 7 5 times and here 4 7 times. By denominator 4 5 times and 7 7 times. Cancel this 5 times of 7 and denominator 5 times of 7 you cancel it and here 2 7s are left over in the denominator even as well as in the numerator 4 times of 5 5 times of 4 and here denominator 5 times of 4 you cancel it. The leftover is 2 4s. So in the leftover in that after cancellation is 4 into 4 by 7 into 7. 4 4s are 16 and 7 7s are 49. So the answer is 16 by 49. Now see exercise 4.2, the standard form. 0.0000000000947. This is a very small number. So you have to convert this a very small number into a standard form. Let us see how to convert because the reading is also very difficult because so many zeros are there. In counting and reading you may miss one or two zeros and you may skip the zeros or counting is also very difficult. In such case, if you convert this into a standard form, then the reading will be very easy for you and by seeing and by converting so that you can easily make out the standard, you can easily make out the number, by this number into a standard form, you can easily identify it. So just see here, 0 point, it is totally 12, that is totally 9 zeros are there and 947. So we have to convert this as first write only the numerical number 947 by in one decimal is there. So in just from decimal onwards you have to count. So write in place of decimal you write here 1 and after decimal how many digits are there? You keep that many zeros including 947. Okay. So here after decimal we have total 12 digits are there. So keep 12 zeros. So how you represent 1 followed by 12 zeros, that is 10 in exponential form, that is 10 to the power of 12. So 947 by 10 power 12. So write this as 947 into 1 by 10 power 12. I just separated it. I have not done anything. You can write this whole thing as 947 into 1 by 10 power 12. Now using the law, 1 by a power n is equal to a power minus n. You have to write this as 10 to the power of minus 10 to 1 by 10 power 12 as 10 to the power of minus 12. So 947 into 10 to the power of minus 12. Now 947 into, in this 947, ones, tens and hundred. That means total 3-digit number. So take out 100 from that. When you remove 100 from this, then you can represent this as 9.47 multiplied by 100. What will you get it? 947. This you learned in 5th class and 6th class level, the decimal multiplication. So 9.47 into 100, how can you represent? 10 into 10. 10 into 10 is nothing but 10 square. So 9.47 into 10 square into 10 to the power of minus 12. Now these two are the common bases with different powers. We can use the law a power x into a power y is equal to a power x plus y. So 9.47 into 10 to the power of 2 minus 12. 2 minus 12 is what, children? Minus 10. So 9.47 into 10 to the power of minus 10. So we can easily read out, we can easily understand the number actually exactly what it is. When it is given in decimals, the reading as well as understanding the number is also difficult. So now when you convert that into standard form, it is easy to read and easy to understand also. Now this is second one. This is a very large number. Even reading also difficult. This very large number. So let us convert this into a standard form. See 543 followed by how many zeros? Total 9 zeros. So right, only the numerical part, that is 543 into 1. This is total 9 zeros. Will represent this as 10 to the power of 9. So 543 into 1 is nothing but 543. So that's why that 1 followed by 9 zeros means nothing but 10 to the power of 9 here. Now again 543. So in this we can remove 100. So that's why we can represent this as 5.43 into 100 as what? 10 into 10. That is 10 square into 10 power 9. Again these two are the common bases and different powers. So we can write this as 5.43 into 10 to the power of 2 plus 9. That means a power x into a power y is equal to a power x plus y. So take 5.43 into 10 to the power of 11. Now, next sum you see children, this is also a large number, 483 followed by 5 zeros. That is, you have to first write the numerical number 483 into, this is how many zeros are there? 5 zeros. We can represent that into 10 to the power of 5. Now, take out again one more 100 from this because it's 483, 483. So that is why 100 if you remove from this, we can write this 483 as 4.83 into 10 square. 100 is 10 into 10, that is 10 square. Into the 10 power 5 left over is 10 power 5. Again, these two are the common bases and different powers. Use the law a power x into a power y is equal to a power x plus y. That is 4.83 into 10 to the power of 7. Now, the next one is a very small number. Again, convert this into a standard form. Just see here. Only numerical number you write 9298 by. In place of decimal you write here 1. And how many digits are there after decimal? Total 8 digits are there. So write 8 digits 1, 2, 3, 4, 5, 6, 7, 8. 1 followed by 8 zeros. Now you see here we can write this as 9298 by how will represent this into exponential form 10 to the power of 8. Now this when you separate this 9298 into 10 to the power of into 1 by 10 to the power of 8. Yes. So here we can use the law a power minus n is equal to 1 by a power n. You can represent this as 1 by 10 power 8 because 10 power 8 in the denominator place. To change this into the to write this into the numerator place, you have to convert this into 10 to the power of negative power by using the law 1 by a power n is equal to a power minus n. So 9298 into 10 to the power of minus 8. Now this is 9298. So 9000. So in 9000, remove 1000 from that. It means take it or separate it, not remove it. Take it out 1000 from this. Then you can represent this number as 9.298 into that removed 1000 into 10 to the power of minus 8. How will represent 1000 in exponential form? 10 cube, because how many zeros are there? 3 zeros. So the exponential form is 10 cube. So 9.298 into 10 cube into 10 to the power of minus 8. Again, using the law a power x into a power y is equal to a power x plus y. Common bases and different powers. So add the powers, that is 3 plus minus 8. Plus into minus is minus. So 9.9229 children here. 9 is missing here. Please correct it. Once again I am telling children here 9 is missing. Don't copy the same thing in your assignment. So this here 9 is missing. So this is 9. This is 9. 9.298 into 10 to the power of 3 minus 8. So it is 9.298 into 10 to the power of minus 5. This is the standard form of the given question. Very small number. Convert into a standard form. 9.28 into 10 to the power of minus 8. Reading is also very, very easy. I am telling you once again, here 9 is missing. You write 9. Here also 9 is missing. Write 9. Here also 9 is missing. Please write 9. Next up. 0. 0.0000529. How to convert this very small number into a standard form? First write numerical part 529 and decimal place 1. How many digits are there total? 7 digits are there. So write 7 zeros. How will represent this in exponential form? 10 to the power of 7. So 597 into, convert this 1 by 10 power 7 into the negative power. That means 1 by 10 power 7. That means denominator is there 10 power 7. We'll shift this denominator 10 power 7 into numerator part. So that's why 1 by 10 power 7 can be written as 10 to the power of minus 7 by using the law a power minus n is equal to 1 by a power n. So 597 into 10 power minus 7. This is 529. 529. So in that again we remove 100. That means take it out 100 from this. So we can write this as 5.29 into this 100. I will represent it 10 into 10, that is 10 square into 10 square into 10 to the power of minus 7. So 5.29 into 10 to the power of 2 plus minus 7. A power x into a power y is equal to a power x plus y. So 5.29 into 5.29 into 10 to the power of 2 minus 7. So 2 minus 7 is what? Minus 5. So the answer is 5.29 into 10 to the power of minus 5. Next one. So, children, the next one is actually how to convert the standard form into the usual form. So that I will explain in the next class. So, children, practice all these sums very well, and until you have to practice so many times. It means as many times as you have to practice until you get all the sums. Practice very well, children. I hope you might have understood all the sums very well. Thank you very much. Thank you, one and all.